Yo, what's up? Welcome to the second stream of my suffering. This is going to be very fun because you're going to see me suffer in a live stream. There's nothing more fun than that. Yo, Bash, what's up? Thanks for welcoming me. You're welcome. Okay, so no, actually, I made good progress yesterday, but off stream. Like I was trying to figure out in what way can I make some kind of diagram which explains the whole code, and I'm trying to use I'm going to try to use the same website I was using for the moveset planning. So I have, let me show you. So I have this, okay, and like for example, this big square represents this script, and I'm going to add blocks, and the blocks are ordered in the same way that the code is ordered. So for example, from here to down here, all of the code is about input buffers. So all of that is represented here by this block. So this kind of explains what that does. And later on, when I start adding more scripts, like if I add, like for example, hit controller was another very important one. So when I add this and this one has its own blocks, then I can like start making arrows that connect one blocks with others, and that way I can know what scripts are related to each other. So this is what I'm going to be doing to organize my understanding of the code, and then when I forget everything again, which will happen because like if I stop working on the code for a bunch of months, I will eventually forget a lot of stuff. So my plan is to organize this in a way that when that happens, I can relearn everything smoothly without having as much trouble as I'm having right now. So yeah, like yesterday off stream, I arrived to this part, which is like this is from the catching system. This is like on each frame while your character is catching. What this code does is it checks on every frame if your C point, which is the point in the space where you're catching the enemy, it checks if that point gets disabled, and if it does, then it resets all the catching variables so that you can catch again a different enemy. So like I just want to have like an understanding of where this kind of code lines are stored, and I want to have that here on this like diagram so that whenever I need to find something, I can just look at the diagram and find it. And I use like this kind of like for cutting stuff, I always start the block with this cutting in red so that I can instantly know where the cutting related code is. So let's continue. This is the last thing I have noted. So then we have this. Let's see what this is. It's dead. Okay, this is related to the death of the characters. So if the character is dead, like there's a flag which is just called dead and it can be either true or false. So if the dead flag is true and the current state of the character is falling, no, isn't falling actually. If the character isn't either falling or lying on the ground, then you change its state to the falling state. So this is when the character is dead, you have to send it to the falling state. Like it's logical. Like if you're standing and you die for any reason, then you have to fall. That's what this code does. I'm not going to document it because it's pretty straightforward. I'll just add a comment. Player is the character is there and sent to the falling state. Then within the logic of the falling state, there's like I remember there's some logic which checks if the death condition is true, and if so, then it sends the character to like an infinite lying stance so that he can't move at all and he becomes a corpse. Then dynamic power level. So this is just a call to the function which computes every frame the stats of the character depending on the current key amount that you have charged. Then current position was the position of rigid body. I don't know what's the use of this. Okay, this is for the render interpolation. I'll just add a comment saying that this is for the render interpolation. Okay. Now we are finally out of the basic Unity functions, and we are finally getting into like custom made functions. So I think for each function, I'll add a block. So for example, for this is grounded function is for the character to detect if they are like near the ground, so that you like this is used for the character landing on the ground. Like you're falling, then your character detects the ground beneath him and lands. So that's why there's a sphere cast. A sphere cast is like your character casts like a ray downwards, and that ray detects the ground. So that's what that function does. So I'm going to call this. mm, I don't want to have big red letters because it's not really that important. I'll just add that and I'll make it bold. And now I'll just explain what the function does. Sphere casts. Yeah, so you get a vector origin, which is the position of the character plus this offset times the locals. Why do I multiply by the y local scale? I guess this is because the character gets stretched on the y-axis depending on the angle of the camera. Vectors, yeah. Okay, so yeah, like this is just some offset, and the offset depends on the angle of the camera. Like, doesn't really matter much. Then, if the character is currently falling or on dash state or jumping, or well, if the character is on a lot of different possible states, then the offset is different. Okay, that's interesting. Okay, I think those are all the states where the character is in the air, you know? Yeah, so like if the character is in the air, the offset seems to change. This is probably some adjustment I have to do back then for the landing to actually work. So generally, you have the offset is this times the local scale plus an extra vector. And then here, isn't it kind of no? Like this vector here is different. Like the y position is different. That's everything that changes. There's this minus 0.2 here. So yeah, like doesn't really matter. This is just some adjustments I have to do. And here we do the sphere cast from the origin. Then this is the radius of the sphere cast, which is like I take the same radius as the character. Bro, why is Unity? Why is it compiling everything? Bro. Okay, so like I take this capsule you see here, and I use the same radius as that one, but I add a bit of extra for some reason. Then this is the direction. The ray goes downwards. Then out ray cascade. Well, I do the out, but I don't really use it. Whatever. Then I don't. I think this is the distance that the sphere cast goes through. So this is 0.8. Like if you see that here, I have this instead of this. It's because I did like lots of adjustments. So first I had one, and then I started trying out different numbers. And then here, ground layer mask. This is so that you can only land on the ground. Okay, there's not much to comment here. This is just like mm, and the important thing is, what does this function return? It returns just a boolean, like, okay, that's all. It returns true if there's ground below, or false if there's no ground below. And that's it. Okay. Next thing we have is flip character. Okay, this function is like probably written like crap because like at first this function was really simple, but then I started adding more functionality to the game, and I have to rotate, like I have to flip everything new that I added. So it kind of ended up being this mess of a lot of things and like rotating. Because as I said on last stream, first I was using 180 degrees rotation, but then I ended up just multiplying the scale negatively. So this is probably not very well written. Okay. Function called in certain states when pressing a movement key opposite to the direction the character is facing. So I think like this returns some boolean, but besides from returning a boolean, the main thing that this function does is when you call it, like you call the function and you specify an x direction, and what this function does is, I think generally it just takes the direction of the float, so like right or left, and it just like if the character was left and you input here a right, then it executes the code that makes the character flip around. And if you just input the same direction the character was already in, then nothing happens. So here, first of all, if you input a 0, then nothing happens because 0 doesn't really have a direction. And then there's this bool should face right equals x direction positive. So like this is just like if the direction you're inputting is positive, that means that the character should face right. And then if the character should face right and like mm, yeah, so like if the character should face right but it's not currently facing right, then all of this will execute to make him turn around. And the other way around too, like if this is false, so like if he should face left and he's actually facing right, then this will also be executed. So like if the needed direction is different than the current direction, then the character will flip. And if not, then nothing will happen. So we can just facing right equals should face right. Okay, this is just me updating the current state of the facing. And the facing right int is the same as the facing right, but it uses 1 and -1 instead of true or false, because in some scenarios it is useful to be able to multiply a number by the sign of the direction. So like right will be positive and minus will be negative. Like and minus will be left. I mean, then you have a curve 3 scale, transform local scale. Okay, yeah, here I start with the changing of the scale. Like what I do is I take the current scale of the character, then multiply the x component of the scale negatively, so it becomes negative, and then I reassign the. Bro, I did this open. And then I reassign the scale to the new negative scale. And this is like the most important part, but then there are like a lot of compensations needed but by the rest of the stuff I added later on. So here we have compensate body scale so that its collider doesn't have negative scale. Mm, what? I don't really know what does that mean. Like what's the body scale? What does that mean? I think body is this component, like this child game object. This one here. So it says compensate. in- Oh, okay, yeah, I know. So like as I said last stream, the different illustration. Well, maybe kind of like the angle is the same, I guess. Like my plan is to make it so it's on its thumbnail. I'm less angered and less sad than the last one. So on the last video, when I finally have rediscovered my whole project, I will be like extremely happy on the thumbnail, something like that. Uh, okay, yeah. So I was saying that generally for the hitboxes, I just need to know if two colliders are colliding or not. That's all I care. So that's why I can like invert the scale negatively because I don't care about the normals of collision. But but specifically this capsule collider here, this one actually interacts with the physics. And if there are physics interactions, then I do need to use the normals. So in order to to the normals for the normals to not get back, I need to keep the collider with a positive scale. Like you see how the character physically interacts with the world. That's because of the capsule collider, which is not like a trigger collider. Like when I punch, let me show you. I'm going to pause it. This when I punch, I can go frame by frame technically. Oh, but I didn't press punch. Bro, I can't pause it quick enough. Maybe now. Yeah, okay. Now, so you see this hitbox from the punch? This one is not a hitbox that interacts physically with the environment. This is just a trigger hitbox. You can see here is trigger. So this only detects if it's hitting another hitbox, but doesn't do anything besides calling like a function with on through the code. But that's all it does. It doesn't physically interact. So I don't really care about if that hitbox is scaled negatively or not, but I do care about the capsule one. So for that reason, I do have to compensate the capsule scale. Do objects not have their own hitbox? What do you mean, bro? Like, the developer is the one who adds the hitboxes, you know? Like, you go here and you add component collider, and here you add the collider. Like the explanation is that you know what a normal is. Like you have a I don't know if like you have this surface. I don't know if yeah you can kind of so a normal is just I need something straight. A normal is just an arrow that points perpendicularly to the surface, you know. So what happens is if you scale negatively this box, like if I scale it negatively and I do turn around, then this normal, instead of pointing like outwards, it will point inwards, and that will mess up all of the physics interactions. So that's why I need to compensate for the physics one, like, but only for the capsule one. The rest don't matter because they don't interact physically with the environment. So yeah, I'm going to add some more comments. Like, I do need to compensate this collider because I want. Okay, here on here I want to add some details on what the compensations are. So first, we calculate. Okay. Mm, why do I rotate this? Like, it's literally a capsule. Like, even if I rotate it, it won't change because it's symmetrical. Like, why do I even do this, bro? I'm not going to remove it just in case there's a reason for it, but I find it kind of not very like useful. I don't know. Okay, then we have avoid the name tag flipping. Okay, this makes sense because like if you flip the whole character, then the name tag which is below here will also flip. So that's why I need to like take the scale of the name tag and change it back. Then avoid the aura flipping. The same with the aura. Like if the character has the aura active, I don't want it to be flipping every time you change your direction, and that's why I also have to compensate here. So like you can see, if it wasn't because of the compensations, this function would end here. Like this will be the end, but I do have to compensate a lot of flipping that's not needed. And active aura scale. Okay, this is like all of the auras. The charging one, the active one, and then this is the UI, like the health bar and the key bar. That also needs to be compensated, and that's it. Like there's nothing else. Just going to write here, bro. Why is the the program writing for me, like keeping compensation. Then there's this commented code which I left in case I needed it, I guess. This is probably my like the original way of flipping I was using, which was rotating instead of scaling negatively, but I don't really care. Okay, guys, we're already at the middle of this main script, so maybe we could finish this one today. It will be cool. Imagine this is gonna be a struggle until you get it down, by which point it'll cease to be. Yeah, exactly. Like, I want to get to the point where all of this code feels natural. Like, back then when I was developing it, it felt natural. Like, it kind of felt like home. Like, every part of the code that I read, I understood what it made. Like, I could see the big picture of how everything, like how all of the pieces fit. But right now, it's just too much to take at once. But like, I'm already way better than I was yesterday, so it's definitely working. And probably the more I remember, like the more I work on remembering, the faster the process will get. Like, the faster I will start to remember more stuff. But actually, like, there are parts of the code which I remember well, like all of the state machine code, which is the thing that changes the state of the character to like from walking to running to punching, all of that. That's probably the part that I remember the most. But then you have all of the code for the the hitbox system, which is pretty hard. And then the catching system is like the worst part probably. And then the beam struggle code, which has two bugs that I have detected and I have to fix. And in order to fix them, I need to remember how it works. Okay, then we have flip around character. Okay, this is just a function that just flips around the character. Like, it just calls the function from before and it gives it the like uh, the inverse direction of what the character is facing right now. So if the character is facing right, this gives us input the left direction. That's why there's a minus sign here. Then bounce of wall. Mm, how does this work? Oh, okay. So like no, like it's the same way. Like this function actually calls the function from before. Like it's the same, but like the function from before required you to add as input like a numeric value of like, for example, on oh, on the function before you could add here a 2, and that 2 will mean that the character is going like at a velocity of 2 to the right direction, or a minus 2 for the left direction. And that will make, and after taking that input, this function will make sure that the character is facing the correct direction. And if it isn't, then it changes the direction. So it changes to be correct. And this one just flips it around. Like, it doesn't matter what's happening, this one just flips it to the opposite direction. That's all that it does. Then bounce of wall, this is like, here I see that it's being played the wall bounce effect, which is like if you've played the game, you should have noticed that when you get sent flying away, uh, you can bounce off walls and there's a sound that plays. So this function is probably what does that. Bro, Little Fighter 2 doesn't use programming. There's no programming on Left 2. Unless you are doing X editing, which is what Dark Fury does, but that's not even like that's the lowest level of programming possible. That's the hardest thing you can do on programming. It's like 500 harder than what I'm doing here. What Dark Fury does. Mm, so like what all of all that this function does is just call again this falling state. Mm, but I guess like the thing is that the parameters that are being like written here are like I don't really know. Like the actual bouncing happens because of the physics. Like I'm pretty sure I have like some bounciness added to the characters when they are on the falling state, and that's what automatically makes them bounce. So I'm not really sure what's the point of this. Like of course playing the sound makes sense, but then why change again to the falling state? I think it's so that the character starts doing like this, when he bounces instead of just staying on the same frame, something like that. Going to add it here anyways, even if I don't understand it very well right now. Okay, player input invoked Unity. Okay, so this part here is like, uh, how do I explain it? So originally, this is about the inputs of the character, but originally all of this was like on the same place as the rest of the input codes. But after I added the AI characters, like the CPU characters, the NPCs, I needed to I needed for them to also be able to call the input functions so that they could input moves. So I had to separate the code for the input calls. Like for example, this function here is the one that gets called when the player presses a move button, and this one is not. Like this one is an apart function that before was like, let's say, inside of this. So I had to split into the functions so that the AI could call this one directly without having to do actual inputs. So this is just for each key, like for move, for jump, for punch. There's like first the callback context, which is like the input system I'm using. So this just takes like on CTX gets stored the button that the player presses. So here I just called this second function by inputting the button that the player has pressed, which is a vector 2. And here move input. Okay, so here I just update this variable, which is what the character uses for moving. and I also store the last move input, which is necessary for some mechanics of the game to know what was your last input. And here on jump, we have a way longer thing. Let's see why is it so long. And I think for yeah, like all of the keys that are not just moving have some more stuff. Probably because all the keys that are not move like are not move keys have like buffers and they also can be held for some time. So yeah, here you can see blast buffer, blast hold time, the key charge. Okay, so I'm going to add a comment here. Mm, okay, then for the jump, we have the same, but like for this kind of single keys, you have the started, and the cancelled. So when you start pressing the jump key, it calls this function with a true, and when you stop pressing it, it calls the same function with false. So that function, if this thing is true, then what it does is it sets the dip jump flag to true. It starts the whole time at 0. It starts the jump buffer at 0.2. The buffers, I have them set up so they go down. So they start at 0.2 and they finish when they arrive to 0. Then the jump not hold. This gets set to true, and then on the next frame it gets set to false, so that it only is true for one frame. So it only counts the moment you press it instead of holding. Yeah, that's it. Then if when you cancel, when you stop pressing, this thing will get called, so the did jump will become false and the whole time will become 0 again. And the buffer doesn't really get, yeah, of course the buffer doesn't matter. The buffer has to continue because the buffer is as you press the key, and no matter what you do, you have 0.2 seconds of buffer. That's what the buffer does. Will you be able to remember all this stuff? Yeah, I actually remember this. I'm just explaining it so I make this like more entertaining. But this part is pretty easy. Like, I don't remember this part. The part that's going to really screw up with my brain is the all of the like the hitboxes, the cutting code, and the beam struggle code. That's like the worst part. Yo, Camlock, what's up? So yeah, here, bro, I'm not going to bytecode the game. I just used bytecode to create apps which I don't really care about. I'm not going to use Cloud, bro. Yeah, I'm also explaining it so that yeah, it's like thinking out loud. That way it gets clearer to me too. Bash is here trying to make me lose all of my brain cells. Mm, so Yeah, like explaining a concept really makes it easier to remember because in order to explain it, you actually need to understand it. You can't explain something that you don't understand. I'm going to add a comment here. It's not whole. Okay, thanks. And here, okay, bro, you have to, you have to spend like 30 minutes every day working on the hotfix. You have to start doing that, and then you can have the hotfix in 1 week. Okay, so let's get past this code because it's all exactly the same, but for the different buttons. Well, there's actually something else here on the defend. I think this is like, yeah, this is some hard coded stuff. Like if you're on idle or walk states, then you get into defend state when pressing defend. Yeah, exactly. You need to actually start doing it instead of telling us you're going to do it, you know? But like the thing you have to do is you have to stop telling us that you're going to work on it and just work on it secretly, and then you can surprise us all, and that maybe can motivate you to do it. Will air recovery be a thing in Epic TVC? Not air recovery, but aerial counterattack. Something like that I want to do. The same way you can counterattack in Budokai Tenkaichi 3. That kind of, or in Xenoverse, I think you call too, or maybe not. I don't remember. No, DBC F2 doesn't have air counters, bro. That's not something that's in the game. That's like a 10-year-old video of a mechanic you never added. I'll show you. Sure, bro. But I don't want air recovery because I find really annoying how you can escape a combo with no skill, you know? I want escaping a combo to need actual effort, not just like having some keyboard chart. Okay, I need to add. No, wait, is key chart different? Like it's the same, but it has less stuff. Bro, why isn't it a link? Why are you saying you didn't send anything? Div keychart true. Keychart holder. Yeah, so here I only have like I don't have a buffer for the keychart button because I don't need a buffer. Okay. Now here there are more controls. I'm going to write input in bold and red. No, not that red, but this one. Okay. I don't know how to call it. Bro, why don't you just send it through Discord instead? Okay, let's get to the next part. We're back at this custom function. This is apply functions. Functions that get called from the state scripts to apply certain movements, like apply the walking motion. Mm. Mm, bro, was that a ghost? What? So let's start with apply walk. Mm, vector 3 input equals new vector 3. Okay, so this is just a conversion from the 2D input to a 3D vector. Then the move is like you normalize the vector and then multiply it by the move speed of the character and multiply by the fixed delta time. Yeah, the aerial combo is just going to be the smash. Like there's not going to be a long sequence of punches or anything. It's just going to be this. That's the aerial combo. But then that will connect into two different possibilities after that. But I just wanted that animation, like a smash animation. Okay, with a single raycast to check the slope of the ground. If there is a slope, the movement vector gets projected onto the slope plane, making the movement way smoother on slopes. Yeah, this is like okay, bro. Like I hate that every time I do the slightest change on a script, everything has to recompile. Like even if I just add a small comment, Unity has still to recompile everything. But at the same time, I don't really care because Unity is so well done that it basically never crashes. Like I remember using Unreal Engine one time, and like I got like a crash every 5 minutes of using it. It was insane. But Unity like has crashed 2 times or something on all of the development of the game. So the thing is, well, there are no actually slopes here. Well, yeah, there's stair, the stairs here. So if I don't make this this raycast read the normal of the surface, then you wouldn't be able to go up the stairs because without that the movement of the character will follow this direction. But if you detect the slope of the like if you detect the normal of the slope, then you can take this direction by this diagonal direction, and then the character actually goes up. And then you have to combine that with some friction so that the character doesn't slide down. Okay, so like, isn't it insane that this is literally Little Fighter 2, but you can enter a building and like do parkour? It's like a dream come true, bro. Unless there are bugs like this one here, like what? No. Yeah, like bro, the stairs suck. Like this, the whole map sucks. It doesn't matter. Like this is just a playtest, you know. Like this is just a very fast model I did in Blender, and I just added a random pixel art texture that I found. Yeah, that's because the house is not aligned. Like it's rotated. So like you can only. Have you ever thought about making all pixel art maps or not? What do you mean? All of this is pixel art. Like all of the textures are pixelated. Don't you see, bro? This is literally pixel art right here. But like I'm going to revamp the style of the maps. I want them to look more like the DBCL2 maps because all of the community wants that kind of style more, which I understand. Okay, yeah. So yeah, like I will change it. And, like I remember. Do you know why the grass is so tall and why it covers so much space? Like this is because I didn't want to use that much grass density. So in order to make the grass like not cover more area, I had to make it very tall. That's why it is so tall. But well, you can always do this if it bothers you. But like on the final game, well, final game on the next maps I do, I'm going to use way less grass. Like I want it to look like this. Maybe some grass, like maybe something like I don't know this, something that's not too annoying, you know. Then I also want like if you are in front of here, I want this tree, this rock, this other rock. I want them to become invisible so that they don't cover your your point of view, you know. Okay, let's continue. I have to continue. Like I'm getting distracted. This is no good. I have to finish this script today. Okay, a play walk. We have a raycast. Mm, so ray origin is like why do I always add this weird quantity? Like what's this? Why do I add that offset in particular? Oh, I think it's because, is it negative? Yeah, it's negative. I think it is because, yeah, like when you start, when you do a raycast, it begins at the origin here. So I want it to begin like uh, more to the bottom, like on this part, and that's why I like subtract this quantity and plus vector 3 up. But then I add some more here, like this is just redundant. I could, instead of having this here, I could just change this to a 2 and delete this, but I have it like this because of all of the adjustments I have to do. Like I have to try a lot of values until I got something that worked fine. Okay, then if physics raycast ray origin vectors, if here we apply the raycast while using magic numbers. What are magic numbers, bro? Magic numbers don't exist. They're only like regular numbers. Okay, slope. Yeah, so the slope normal is just the normal of the raycast of the, like when you do the raycast, the heat of the raycast gives you the normal hard coded numbers. Yeah, they are hard coded numbers indeed. Oh, okay. Yeah, I know what you mean. I could do that, but not right now. Mm, so yeah, here you get the slope normal, then project move vector onto the slope. So this is just the projection of the movement vector. Then here we have, well, I'm going to start adding here the corresponding block. Okay, then what is this? Target pose. Okay, this is the part which actually moves the character. Target position is the current position plus the movement. Then there's a sweep test. I think the sweep test is for like not being able to not pass through walls or something, but I'm not sure. Like I know that if you go very fast, like if you're using Gogeta, you can go through walls. Right now, I have to solve that at some point. Maybe not on this version because I have a lot of other stuff to do. But let me charge to maximum power. Let's see if Vegeta can go through the wall. Maybe he can, or maybe he cannot. He can. But like Gogeta can do it. if you power up to maximum. So sweep test. I don't know how a sweep test works, but I think that was the intention behind it. No, it's not for. Like, I'm just using it to avoid going through walls. I think like a sweep test just takes like a shape or something, sweeps it across the space, and checks if the swept space hits any other surface. I think that's what it does. So what I do is if sweep test is false, so like if there are no surfaces in the middle of the trajectory, then the character moves or something. Or hits a normal. So this sweep test gives out this hit 2, and the hit 2 gives you a normal. So the see here is if the normal is the y component of the normal is bigger than that, why do I care about the y component of the normal? Let me think. Okay, yeah, like if this happens, that means that it's not a vertical wall, but that it's like a diagonal wall. And if the wall is diagonal, then you don't want the. If the wall is diagonal, then you don't actually want. Bro, you don't actually want the character to be stopped because maybe you want to go up some stairs or something. Then you have hit to collider game object layer. What? Oh yeah, like this is just like for only the text, bro. This is layer different than 6. Layer 6 is probably the ground layer. Yeah, exactly. 6 is ground. So if whatever was detected is not part of the ground, then it doesn't matter. How can I comment within a single line? Like, can I write a comment in here? I don't think that's possible. Just going to write it here. Okay. Then if there are no problems with the sweep test, like if there are no walls in between, then the character can move. But like this sweep test is not perfect because as I said, if you take Gogeta and power him up to the maximum and stomp yourself against the wall, you can actually go through it. So I remember back then I thought of a way of fixing that, but I don't remember right now. So probably this part of the code will get changed in the future. Probably. Right now I'm going to add it here. Make Vegito be able to no click. Why? Vegito doesn't no click in the anime. Okay, else. Okay, if there's a wall in between, what happens? Then, okay, I have a vector 3 called direction thingy. That's very useful. Okay, direction thingy is just the normal of the surface you just hit. What is this, bro? Move position. Okay, instead of just using the target position, you use the target position minus a dot product of the move. Yeah, that's the magnitude, but what's this direction? Mm, so like, okay, I think this is just a force that pushes you. Yeah, this is like, this thing is, if there's a wall in between, then there's a force that pushes you outwards of that wall. Something like that. Okay, then we have apply run, which is basically the same as apply walk, but instead of move speed, you use the run speed. And there's some other stuff like, for some reason here I have the facing right. Mm, okay, so this is basically the same function. Like I don't see any difference. He runs like a regular Little Fighter 2 character. Like it's the most standard running animation possible. Uh, no, I don't think. He points his fingers out. Wait, let me. Uh, mm, it's here. Yeah, here. So yeah. Okay, bro. Why do I keep misclicking everything? Is looking raw something good or is it bad? I'm not familiar with the term. Okay, this kind is the same as the walk one, right? Or do I use the ball in? Yeah, I use the ball in. Oh, okay, so the ball in is just for like the X direction. It's good, means like badass. Okay, that's great. Okay, so here for running, as you may have noticed if you've played any game like either DBC2 or Epic DBC, when you run, your character keeps running on the same X direction. Like you just press 2 times to the right and it keeps running to the right, and that's it. So that's why here the X velocity is not dependent on your input. It just depends on the facing of your character. So if your character is facing right, he will keep running to the right. So that's the only difference between this function and the other one. Then you have some weird functions here. Apply residual walk. So this is like when you stop walking, uh, I didn't want the characters to stop abruptly, like, you know, but instead I wanted it to be like a smooth stop. And for that, when the character stops walking, I apply a residual walk. So like it's an extra push, an extra force, not force, that I add so that the player doesn't stop moving. It's another reason why I recommended buttons for because running is harder. Bro, it's literally the same. Like I play on mobile from time to time, and like it can't get easier than it is. Like playing on mobile is just worse than playing on PC. That's how mobile is, you know. You can't make it as good as a keyboard. It's impossible. At force, bro, you don't have to drag the joystick. You literally can press. Like, have you even played the game? Wait, can you see this? Well, okay, if I hold it here, you can. So, okay, let's try this. Look, it's very, very, very easy. Wait, I need. Let me kill Vegeta first. Epic gameplay. Yeah, I think he's dead. No, he's alive. Okay, he's dead now. So, look at this, okay? I'm going to press. I'm not going to drag, but I'm going to press 2 times. So, look. Wait. You see, I just pressed. You don't have to drag, bro. You just press 2 times. It's so easy, like, it's insanely easy to control. Bro, you are literally dragging this whole time. There's no way. Like, I made it so easy to use. And you drag instead of just pressing. Okay, let's continue. I want to finish this section already. Apply residual walk. So here, okay, this is why I care about the last move input so that I can apply these residual walk forces. My camera move. Oh, epic camera. Stop. Yeah, now it's stopped. You're welcome, Delta. Okay, so you take the input. The input is just the last move input. So when you stop walking, you just use the last walking input that you used, and then move, you multiply it by the move speed and like divide whatever, and then just apply force. And that's it. Like there's not much more to it. I'm going to mention the apply run. Is the play residual run the same? There's a timer. Why is there a timer here? What? That's so random. Oh, okay, so I feel like this function is getting called like multiple times, not just once, or something like that. That's why there's a timer. So like the smaller the timer is, the smaller this move is. And this is actually using move position instead of add force. For some reason, like you can see there's a commented I add force, so probably that gave me some problems. So yeah, like instead of just adding a force on one frame, this probably gets called on each frame with a timer that decreases every time until the timer reaches zero, and then there's no more force being applied. And probably there's a reason of why I do that, which I don't remember right now, but it doesn't really matter. If it works, it works. And apply air XC movement. So this is when you jump, I actually allow you to move horizontally, but like you move slower. And I did that so that the parkour is easier. You know, like when you jump, like notice I jump straight up, but I end up moving in the air. So that's what this function does. So it just takes the input, and this velocity is not dependent on the velocity of the character. All of the characters move at the same speed while in the air. And then there's what's all of these conditionals. There's two different add forces. Yeah, this is probably because like I separated the X component of the C component for some reason. I don't know why exactly. What? Why do I need these two conditions? That's so random. Oh, oh, okay. Oh yeah, like I understand. So these two conditions are so that you can't move as fast, like so that you can't continue to accumulate velocity above a certain like threshold. Because before adding these conditions, you could literally accelerate a lot after jumping because there was like no limit on the speed you could get. So I had to add these two conditions. I'm going to write it. Yeah, because like if you fall from a very high ledge or something, like if you climb the house and then drop, and there are no these and these conditions aren't here, then you can just accelerate a lot because you have a lot of time until you reach the ground. Will Epic DVC have standard balance and realistic versions as well? Yeah, it will. But not right now because there are not enough characters for it to make sense. But like adding it to this game will be a lot easier than DVC 2. And actually, I was thinking instead of just having three different versions, like I could literally add a bar that you can scroll, like and like this. The minimum of the bar is balanced, and the maximum is realistic. So you can adjust how realistic you want the power levels to be. That's a possibility that I could do, maybe. But maybe it's like too much. Maybe I just do three versions and that's it. Okay, then apply jump. Okay, this is for when you jump, of course. This bullet equals false is because you can jump from a lead. Like if you're holding to a lead, you can jump from there. Okay, so vector 3 input, of course. Then xy velocity, if lead is false. Yeah, so like when you jump from a lead, this is a thing. So originally I had the same jump force for every kind of jump, but then the problem is that if your character is too weak, he couldn't really surpass ledges. So if you hold from here, if your jump wasn't high enough, then you couldn't really go over that ledge. So I had to make like a standard jump height from ledges so that every character could climb. So yeah, that's it, guys. Mm, okay, yeah, pretty straightforward. Okay, we have finished this apply movement functions section. Then we have this search left function. This is for climbing. This is like the raycast, which detects ledges. How much there is? Okay, guys, I need a rest. Let's do geometry dash break. I'm kinda addicted to geometry dash again for some reason. Kinda appeared on my feed. They have a mod which limits my amount of playtime so I don't get too addicted. Just 10 minutes and I'll be back. I'm beating this pretty crappy demon. It really sucks. Bro. Transitions are ass. Like, this is the worst demon I've ever played because the UFO gameplay is complete ass. Like, so bad, bro. Bro. Used to want to complete every level with 3 coins. I kinda like I don't have all the coins. I don't even know where some of them are. I haven't completed this one, bro. Like, I did in the past, but this is like a new account. Like, I don't have the coins. Like, I just I don't even have completed this level on this account, bro. It was. Bro, do you know where the? Why do I have the first 2 coins of all of the demons, but they don't have the third one? Well, whatever. I don't care about coins. I'm like, I have this thing called GGDB, which like orders of the demons, all of the custom demons of the game in difficulty tier, and you have to like beat them in order. So like I consider it like an expansion of the base game. It's pretty fun. Bro, why do I die at the easiest parts? Oh wait, you can't see the game? It's black? What? Why is it black? Is OBS stripping or what? Why is OBS not showing anything at all? What? Like it just becomes black? Let me try window or something. Wait, how do I even change that? What? Why is this not working? What is happening? Nothing, I was just resting a bit on geometry dash, but like OBS doesn't detect the game or something. Maybe I can add I don't know, I'll just make it window. How do I do? Epic window. Yeah. Okay. it got crushed. Oh, what a fail. It worked. Yeah, it works. It's just 8 minutes of chilling and then I'll be back to the suffering. Bro. If this level starts, I'm just going to practice the last part. So that when I get there, I can just why am I getting into black? Bro, the window mode is making my game lag. Maybe it's because of the all the transitions on this level suck so much. Like, why does the white path to start as reverse so unintuitive? Why do you have to hit an orb with a wave? Like, it's so stupid. It's just a stupid game design. It's so hard to hit. Bruh. Bro, I'm already practicing. Don't you see I'm starting literally on the 64, 64%. Why? Like, I can already beat the part after this, it's just that I want to be able to beat it on all in a row. Like, I already know the inputs, I just need to put it all together. But the problem is that, like, I think it's because of Windows mode, I'm getting input lag, so it's way harder than it should. Into second wall. How is geometry that's better on mobile, bro? Like, on mobile you only get like 16 error. Like, this is a game that you have to play on as many FPS as possible. Yeah, finally. We have 35 seconds left before the timer mode makes the game stop. So I need to try the whole level now. Bro, like, this second UFO part is so messed up. Okay, it's over. Back to the suffering. It's like one. What level is this? It's one of the worst easy demos I've played. Like, so annoying. Like, it has some free parts to it that are extreme. Bro, you think this level is distracting? If you think this level is distracting, you haven't seen anything, bro. Like, this level is so simply decorated. Like, it barely has any elements to it. Okay, so I was on the search left function. So this probably just does some raycast. Of the origin, I don't care about where I put the origin. You have box sizes. Mm, you got two different box casts. I know what a larper is. Bro, what is this? There are two box casts. There's left, right, and what? I guess that's right and left, or epic. Like, do you play only the base levels, or do you play custom levels too? That was not my question. I asked if you only played the base game levels, or if you also played custom levels. Yeah, then you are a LARPer if you only played the base game. You kinda are a bit, like not really, but kinda. Hey bro, the base game demos are the start of the game. Like that's only the start of the actual suffering. Yeah, like originally when I first played the demons, I probably it probably took me around that many attempts for the hardest ones, but like right now I can beat them in like a few attempts because they are pretty easy in comparison of what you can find on the custom levels. Like bro, search for example, search on YouTube for tidal wave, which is like the top four level right now, I think. But it's pretty impressive to look at. Like search for it, bro. Trust me. It's the fourth level right now. Like there are even harder right now, but like that one has stuck to me because it's very impressive to look at. Like after the drop, when you get into the wave, bro, bro, everyone feels inferior after watching that level. I don't know how does this work. Why are there two box casts which do the exact same? No, it's not the same. What, bro? Why are the two? Why are there two consecutive box casts? You don't get it. There are no comments explaining, and the AI is not helping me anymore. Like I don't get the point of this first box cast if the second one instantly overrides the first one. Like what's the point? I'm going to try something. I'm going to like delete this line and let's see if something breaks because it just doesn't make any sense. Yeah, it still works. So it was literally like it was like garbage code. It was just calling a boxcat, which is one of the harder like it's an operation that consumes a lot of resources, and I was calling it two times for no reason when only one time was needed. Like what? What's the reason? I don't get it. Like the climbing works exactly the same as it did before, but now I deleted an like I deleted a whole box cast and it's still working. Like the only difference between the two box casts is that the the box size is different on the second than on the first. That's the only difference. But like it gets instantly overwritten, so it doesn't make any sense to have it. So if something if a let's is detected and the character is going down and not up, then mm, transform position. Okay, the character position changes and the let's climb state gets called. So let's take note of this. Okay, next function double tap. So this is the function which makes the double tapping work for like running. So I don't know. Maybe I can just skip this because like this is a very isolated function. I think I don't think I really need to understand it right now to get the whole thing. I remember it was pretty confusing, Double tap function tracks if the player double taps left or right buttons. Like this was pretty confusing. I'm sure of that. Right input. If you are pressing right and there's no current double tap right, and then double tap timer right, you get the current timestamp, and then you like there's this flag which is not a flag because it actually can take three values, three, one, or two. So after you press a single time the right key, and then this flag goes from 0 to 1, and then the one from the left goes to 0. Like if you press right, the flag for the left gets cancelled. And then if you okay, so if you press once, it goes to 1. If you stop pressing after pressing once, it goes to 2. And if you press again after it's already on 2, then it goes to 3. And when it's valued on 3, then I think it already counts as a double tap. Like you press, stop pressing, and press again. And then there's something else. Yeah, so like there's a timer. So if 0.3 seconds gets surpassed, then it gets cancelled. And that's it. Like it's actually pretty easy to understand. I'm going to just write. Okay. Now here, like I remember this function way more confusing, but I think it's because it kind of took me some time to get it working, but now I read it and it makes absolute sense. I don't need to get into details here. It doesn't need to say that. Okay, we're already at line 1,000 and like 11,000, 1100, sorry. Okay, we're at the teleport functions. I actually think I'm going to skip this because like it's not really important right now. Like I'm aware of what teleport does. It's just a function that you call, and how many lines are left? Uh, some of them. I don't know. There's a bunch, but this like starting from here, it's like very isolated functions that do very specific stuff, and I don't think I really need to understand them right now. Like, if I need to understand how the teleport works, I can just come here. Like, I know where this function is located. That's what matters. So I'm just going to write here what this function does because I already know. Bro, are you maybe you are, but just in case, are you aware that this is just the first script of the like uh 15 50, not 15, of the 50 or so scripts I have to relearn? Like, this is the first one. But did you think that the whole game was just 1,000 lines of code and that's it? Like, bro, what are you smoking, bro? And also there's this close teleport function, which is the same but only teleports you if you are close to the enemy already. And this is basically for like close range teleports, like the counter attacks. Okay, then this is some helper functions for parsing strings into other variables, so I can skip those. And now we get to the O-point function. We have broken instant transmission. I think I actually just forgot to add the instant transmission Kamehameha, but I should add it, maybe, or maybe not. I will see. Like, I didn't even add regular instant transmission. Actually, right now, I can't add it. Like, with the code I have, I should call that teleport because, like, this teleport function only teleports you to the last enemy you have hit. Like, this is a teleport for comboing, not for instant transmission. But you know something cool? I could make it so that you can somehow select what enemy do you want to teleport to. I don't know how cool that work, but I could try doing something like that. Okay, try. Yeah. So the O-point function. So this is not actually the function. Like, O-point means spawning things, either characters or blasts. Like for example, characters in DBCLF2 can shoot blasts, but also Krillin can use the multiform, so he can like copy himself. He can spawn copies of himself. So all of that spawning things is a point, but this is not. Yeah, like the term is from LF2. So like this is not the function that actually spawns it. I think because there's a whole open script that manages the spawning. This is just like some kind of helper function which connects the main script with that other class, I think. Nah, bro, like nothing on left 2 is complicated. You just need to like write numbers and that's it. There's no logic. Like a point on LF2, you just have to like specify the point at which like the position where you want to spawn the thing and the ID of the object you want to spawn. Like there's nothing else. Okay, parsing. Okay, yeah. Okay, yeah, I know what this is. This is the function that you call through the animator. Let me show you. Like this is really cool. The way I use the animator to simulate the way that a thinking works, it's pretty cool. Like for example, let's take the keyboard. Where do I have the here keyboard? So here Vegeta uh, shoots a keyboard. So here on the timeline you can see these funny things here, which are events. So this is event calls. This is just calling a function that's inside the script of the character. So here, this one is a call to appoint. So here, what I'm appointing is I'm calling the function and I'm passing this parameter. First, it has the name of the thing I'm appointing. This is the like the actual key blast is here. It's the same key blast as Gogeta's because probably because I didn't feel like making a new one. Or I don't remember how the damage works. Yeah, actually the damage of the blasts you spawn depend on your power level. So that's why I'm using the same blast as Gogeta's because Vegeta's power level is smaller than Gogeta's, so automatically his blasts will become weaker. So here you have like the the thing you're spawning, which is the key blast. Then this is an offset, which I have set to 0. The offset, I just have it in case I try appointing multiple objects in the same frame. But if I just appoint one, then I just need to move this object wherever I want the point to happen. And then the last thing it says true. Let's see here. Okay, this is the facing. So if you say true, then it faces the same direction as the character is facing. While if you say false, it will shoot to the back of the character. And yeah, so that's like the parameters. Now let's see what does happen here. I'm going to add here. Like this is an important function because it's related to something else. So I'm going to use these red words into say point and point offset facing. So let's see, facing right input. Okay, this is what checks the current facing of the character, and depending on that, it spawns it to the right or the left. Then this is the same but as an integer. Then corrected position offset. Yeah, so like depending on the facing, you have to correct the position offset, of course. Like if it spawns to the left instead, you have to like multiply negatively the x position. Then the position is the point position plus the corrected position offset. Okay, because we were talking about the offset. Yeah. Then prefab. Yeah, here I load the object that they want to spawn. Actually, there's a huge problem in Unity. When you spawn an object, it gets the game freezes for a second if it's the first time you're spawning that object. That's why in the loading screen, I try to spawn all of the objects that are going to be used, and that kind of fixes it. But at the same time, it doesn't perfectly fix it. Sometimes you can still notice the problem. So that's something I can look to improve in the future. For now, it's okay. Like there are some lag spikes because of that, but it's not something too huge. Then yeah, you load the prefab. Then last point the object. Okay, and here it is. This is the part where you actually call the actual appoint function, which is not on this script. It has its own script, which is probably here. Yeah, here it is. This is the actual appoint script, which I will be looking at later on. For now, I'm just going to add this here, and in the future, I can like connect it with an arrow to the actual class. So what this does is I got lost. Okay. Loads the prefab and false function open fire. And then apply the BFX particle emission multiplier from the graphics settings. Okay. This one's a bit weird. Like, there's a graphics setting for like BFX for like the amount of particles, and I think this line applies that, but I don't know how that works. Oh, okay, yeah. So here, probably class, this function is returning a reference to the object. Mm, yeah, it returns the reference to the object. So here, VFX emission multiplier. You can go look at that. So I have to go to the root singleton. It's here. Now how is it called? VFX. Okay, this is probably on the graphics setting. Yeah, here. So basically what this does is it calls this function here, passing it the blast that you just spawned. Visual effects. Okay, so it first of all it checks if oh okay, so like a blast object can have multiple BFX attached to it. So this function goes through all of them, and then it uses a loop to iterate over them. And for each BFX that it finds, it it finds the emission multiplier, which is like it's a parameter I use for my BFX, and it sets it to the correct graphic setting. That's what it does, so that I can limit the amount of particles emitted depending on the graphic setting. Okay, that's cool. I'm going to add that to here. Okay, there's yet another helper function which I will skip. Then we have the freeze function. So what is this? Freeze axis functions. Bull trash. Bro, that's such an epic name for a flag. What? There are not even comments? Like, I remember this is a function that you can call. Oh, I think I know what it is. Like, this is on on the LF2 that data changing. You can set a velocity value to 550 in order to freeze that the velocity on that axis. So this freeze function does something like that. That's why it uses straight parse vector 3 and bool. Like here, you pass a string because the animator can only pass strings, but then this string gets converted into a vector. And then, like for example, on that vector, you can set 1, 1, 0, and that will mean that the x component stays the same, the y component stays the same, but the c component goes to 0. Something like that. Mm, try parse vector 3. Okay, and then linear velocity is vector 3 scale. Okay, yeah. So I use a scale function which takes the current velocity and scales it to the ratio of the freeze vector, which is the thing you input here. Okay, yeah. I'm going to add this. Freeze. Okay, next function is add impulse fuck. Yeah, bro. Epic name. Like, what's this? I think this is also for. What's the use of this function? I think I'm just going to ignore it. It takes a vector of 3 and it just adds the force. Like, why does this function exist? I don't get it. I'll just ignore it. Okay, blink. Okay, this is for the blinking of the character after you get up from the ground. So this is just a coroutine. Let's see how it works. Float timestamp. Okay, so the blinking flag is a global variable that every other script has access to. So when it's true, basically your character is invincible. The hitbox script checks for this flag, you see. Then while time is less than the timestamp plus the blink time, then this thing happens, which basically makes the character blink or something. This alternates between alpha 1 and 0 on each iteration. Okay, perfect. Then there's probably a sleep. Yeah, you'll return new, wait for seconds, 006. So yeah, this just changes the alpha from 1 to 0 to 1 to 0 to 1 to 0, and that's it. And when it finishes, it gets back to normal. It returns to the original color and the original alpha, and yeah, there are some color changes or something that I don't remember how they work. They don't care right now. Like, that's not important on this moment. Okay. Blink time. This sure is a lot of stuff. No wonder you spend the whole summer. Yeah, exactly. And you're only seeing the final state of the code. You didn't see all of the failed tries that I had to do on a lot of stuff. And also, you don't see all of the debugging I had to do to figure out what the hell was wrong with some of the code. But well, you will see that once I start expanding the current game, which will happen in like 3 years whenever I'm ready to start modifying the code again. Okay, active aura. Okay, we're already at the aura functions. This is almost the end of the script. Like, guys, this is the biggest script by far. This is full of different types of functions that do different types of stuff. In 3 years, I hope we'll finally have gotten But that's such a random request. Like remaster Ultimate Blue. Yeah, I hope so too. Like it's so much gold. But like other scripts are usually this long. Like for example, I opened this random script and it's only 100 lines. Mm, mm, like there are only like around 10 actual problematic scripts. Like this one, the hitbox one is very problematic. This is going to give me a very big headache. As you can see here, hitbox activator. Like there are some scripts that are pretty short. Whoa, look at this script, bro. It's so hard to understand. I need some help to understand this script. Bro, if you knew how many times I crashed out during that summer, like I literally got PTSD from Unity. Like generally, scripts are pretty short, as you can see. Yo, Lifeful, so are you fixing bugs or, bro? Do you know how to read? Just read the title of the stream. Like, it's not that hard to read. So, bro, we have to play Dynasty Warriors. You have to stop making excuses and start playing because it's the best game in the world. Okay, so let's see the aura. Like the aura is a bit weird because I don't think I can really understand anything here unless I first go through the aura script. I think because like let's see. So here, for example, there are calls to there is a call to a start charging aura function, but I don't know what does this function do. He charged aura banner. Is it always the same script? It's this script. It's not even that long. I remember this was very confusing when I first coded it. Maybe I could read this script before getting into these functions. This is just charging aura. What about the active aura? Mm, like, why is it called start charging aura if it's for the active aura? I don't get it, bro. I need to try understand something here. VFX pre-warm time. Okay, yeah. Mm, timer vanish time. So start starting aura thus already stopped false. If game object active self set active. Where's this script even attached? Like, is this part of the aura object? Keytar's aura vanish? Yeah, exactly. So this same script is attached to every single aura, like the active one, the keycharge one, and the flying one. So all of them share the same script. Like all of them use their own. Like they don't share the same one, but they'll have their own instance. So this first of all, this sets on the aura object. Mm, and if it was already on, it uses this rainit, which I don't know what it is. What's left aura right off? Oh, they are visual effects. Okay. And timer, vanish time. I don't know, like this uses some functions which are from the visual effect, but I don't remember what do they this. Well, it's actually just yeah, this is just setting a like a parameter from the visual effect from the VFX graph. So this sets time to 0. Mm, and I guess then the graph does something depending on the time. Yeah, probably there's like a fade in and a fade out depending on the time. They really don't need to understand this now. Like the auras work fine, and I don't think I need to change anything about them right now. So you can just ignore it. Like spawn. Okay, first this spawns an aura explosion, then active aura start. Yeah, active aura mode. This is important because the active aura mode gives you a 25% stats boost. So there has to be a flag for it. Then render material. Your material has to change because the aura colors from the character are like more shiny. Then UI controller active aura field. Okay, yeah, this is for the second bar of the keybar. Then the stop active aura. Then control active aura visuals. What's this? Oh, this is like if you have your active aura and you start charging keys, like key, the active aura has to vanish away, and then when you stop charging it, it has to reappear. So if your inactive aura and this function is called, then mm, well, I don't know. Oh, there's this parameter here. Okay, yeah. So you just tell it if you want to enable it or disable it, and that's it. Just going to write like a very high level explanation of all this. Control active aura visuals animator. What's that? Isn't that the same? Or oh yeah, it's literally the same but for the animator. Okay. Full into functions are for using the keytart's aura during custom moves. Oh, okay. I don't even know where does the keytart's aura get called. Probably gets called on a different script than this one. Mm, okay, this part is interesting. This is, for example, for Vegeta when he chases during his aerial combo, he has like this aura with a trail. So this is the logic of how he moves while he's chasing. So first he gets the distance vector between the target and him, and then he moves his position by a move mount, which is a parameter here, in the direction of the enemy. Mm, and then if wait, what is this return value? 4 2. 0. That's so random. Oh, okay. Yeah, so like that's just because I need to return a specific value in case the distance back, like in case Vegeta is already close to the enemy, because then he has to stop flying. And aura taste visuals. No problem. Mm, I'm kinda dying right now, but I want to finish this. It's almost done. Mm, Okay, now there's a compute stats function, which I'm not really going to go over because it just takes the stats and multiplies them by like and scales them proportionally to your power level. This is just a function you can call from the animator to like deplete an amount of key from the character, and then there's just this sound play sfx function, which probably calls a different function from a different class. So you get sound ID, volume, and time, and this is probably so that you can call it from the animator, I'm pretty sure of. Like, let's see what's something that should create a sound here. Yeah, exactly. Like, this is a function for playing a sound from the animator. Okay, so we are done with this huge script. Now, before finishing, I want to see what would like look at this, bro. This is all the explanation of how this script works. Each block is like a bunch of code which has a specific functionality. So now, uh, probably the next thing I should look at is the state machine, because that's the second thing I coded, I think, and it's what makes the character work. Like it's what makes you able to use the character and move with him. So probably I'm going to do the state machine. Then after the state machine, I'll do the hitbox system. Then after that, probably the catching system. Then after that, I'll have to look at the how the key blasts work. And that's probably the current roadmap I'm going to follow. But yeah, we're done for today. So thanks for watching. See ya on the next stream.